We are here with Law of Radioactive Decay once again on YouTube. Rutherford and Soddy studied the phenomena of radioactive decay in detail and formulated the following law known as radioactive decay. First law is radioactivity is a spontaneous phenomena and one cannot predict when a particular atom in a given radioactive sample will undergo disintegration. Means it is a spontaneous reactions और इसको कोई प्रिडिक्ट नहीं कर सकता जब कोई एटम डिसइंटीग्रेट होता है. व्हेन ए रेडियोएक्टिव एटम डिसइंटीग्रेट आइदर एन अल्फा पार्टिकल और बीटा पार्टिकल, इस इलेक्ट्रॉन कहते हैं बीटा पार्टिकल को, इज एमिटर. थर्ड है about second law explanations. There is the new atom so formed called daughter nucleus या daughter atom may emit a gamma ray called photon. In this case, nucleus is left in exact state. Nucleus is left in exact state on emitting the alpha or beta particles. Further, alpha and beta particle never emitted simultaneously. It may also be pointed out that radioactive atom can never emit from more than one alpha or beta particle at a time. It may also be pointed out that radioactive atom can never emit more than one alpha particle or beta particle at a time. Now third law है is emission of an alpha particle by a radioactive atom result in a daughter atom whose atomic number is 2 and mass number is 4 unit less than that of the parent atom, less than that of parent atom. So due to alpha decay, we have ZXA, that is the atom alpha decay. It gives daughter nucleus with Z minus 2, A minus 4. So that is called daughter atom. Daughter atom. Fifth number, this number of atom, this number of atom disintegrating per second of a radioactive sample at a time is directly proportional to the number of atom present at a time. So rate of disintegration of the sample cannot be altered by changing the external factor. Rate of disintegrating of the sample cannot be altered by changing the external factor such as pressure, temperature, etc. It is known as radioactive law, decay law. So ये जो फिफ्थ लॉ है, दिस नंबर ऑफ एटम डिसइंटीग्रेटिंग पर सेकेंड, जो भी नंबर ऑफ एटम पर सेकेंड डिसइंटीग्रेट होते हैं ऑफ ए रेडियो एक्टिव सैंपल एट ए टाइम डायरेक्टली प्रोपोर्शनल टू द नंबर ऑफ एटम प्रेजेंट एट दैट टाइम. रेट ऑफ disintegration of sample cannot be altered by any pressure, temperature. These are the external factor. So what is radioactive in mathematical expression? Expression of radioactive decay law. So consider that radioactive sample contain N naught atom. N naught atoms initially starting में when time is 0, स्टार्टिंग में जब टाइम 0 था तो रेडियो एक्टिव एटम कंटेन N नॉट, रेडियो एक्टिव एटम N नॉट सैंपल है, एटम्स है सॉरी. सो एज द टाइम इलैप्स, जैसे जैसे टाइम चलेगा बीतेगा, टाइम इलैप्स, द एटम ऑफ द sample decrease जैसे जैसे टाइम इलैप्स होगा डिसइंटीग्रेशन स्टार्ट होगी और जो एटम होंगे सैंपल के वो डिक्रीज करेंगे ड्यू टू disintegrations. Suppose that after time t, number of atom reduced to n, number of atom reduced to n, and after time t plus dt, the number of atoms further reduces, decreases to n minus dn. So it is obviously in the time interval between t and t plus dt, that is equal to dt, the number of atoms decreases by n minus dn, n minus dn, that is dn, that is the in time dt, that is in time dt dn atoms are disintegrate, therefore rate of disintegration of atoms at time t is dn upon dt. According to radioactive decay law, dn upon dt directly proportional to n, that is here this number of atom disintegrate per second, dn upon dt, number of atom per second is directly proportional to the number of atom present at that time. So that is dn upon dt, therefore dn upon dt is equal to minus lambda n, where the constant of proportionality lambda is called decay constant. Decay constant of the radioactive sample, it is also known as disintegration constant. It is also known as disintegration constant or transformation constant. transformation constant. Its value depend upon the nature of the radioactive sample. Its value depends upon the nature of the radioactive sample. Now, from the equations, from equation 1, we have dn upon n is equal to minus lambda dt. Number 2, integrate the equation. So dn upon n minus lambda dt so log of e n is equal to minus lambda t plus k, where k is constant of integration and its value can be evaluated. So when t0 n is equal to n naught, on putting t0 and n equal to n naught in equation 3, we have log of e n naught is equal to minus lambda into 0 plus k. So k is equal to log of e n naught. Therefore equation 3 becomes log of e n minus lambda t plus log of e n naught. Now log of e n by n naught, you know how we solve these equations. Log of e n by n naught equal to minus lambda t, and n by n naught is equal to e raised to power minus lambda t. So what is n? N is equal to n naught e raised to power minus lambda t. That is equation number 5. The equation 5 gives the number of atom present after time t. Now graphical representations, that is the time t, that is the number of atoms. When time 0, there are n naught atom present initially when time is 0. As the time elapses, the atom disintegration started, and it is like this up to infinity. Meet at infinity, and disintegration is continuously. When half time changes, so you can graphically represents when half time is elapsed. the number of atom present that is and not by 2 half time. So that is the graphical representations. So thank you very much. नेक्स्ट टॉपिक के साथ हम फिर मिलेंगे. ओके बाय.